Okay, tape 64 is solving quadratic equations by factoring. So let's go through these examples. Now, looking at example 1 and looking at your notes where you have those 4 steps, you might say, what we're doing here, starting at step 2, we're going to say, if you have it factored, here's the process. So let's look at number 1. So if I have this parenthesis times this parenthesis equals to 0, if you're going to multiply two things and get 0 for an answer, then one of those has to be 0. Well, then what we'll do is come down and set that equal to 0 and set the other factor equal to 0. And what we're going to say is, well, that one's 0, or that one's 0, or both of them are 0. But you set each factor, multiplication, equal to 0 and solve. So r is equal to 6, moving the 3 across, and then dividing both sides by 2, we get r is 3/2. So the final answer should be written r is equal to 6 or r 3/2. In other words, to make that problem work, r could be 6. Okay, so it would be 0 times 15, so that's 0. Or r could be a minus 3/2. That would be 0 times that, which would still be 0. So the answer is r is equal to 6, r minus 3/2. Okay. Both of them could be true. All right. Now let's take the second example, and now let's start with the first step of the rule. And here's what we're going to do all the way through these examples. You must get all the letters and numbers on one side equal to 0. Before you start this process of factoring and setting each factor equal to 0, you must have everything to one side equal to 0. When we have that, then we look for factoring. Now, of course, if it doesn't work, if it doesn't factor, then you have to do quadratic formula or some other method. But this tape is showing you when it factors, this is what you do. So setting each factor equal to 0 and solve. Moving the 3 across, we get 3. Moving the 1 across, we get a minus 1. Therefore, the answer is y is equal to 3 and minus 1. Well, let's look at, see if that checks. If I go back to the original problem, I would have 9 minus 6 minus 3, correct. If I put a minus 1 in there, I'd have a positive 1 plus 2, checks. All right, so let's look at example 3. Now, example 3, we have it all set equal to 0, so we look for factoring. Well, remembering factoring, the first rule is to look for a common factor, so we can divide a 2 out of this. And now we look to use the FOIL method. And so this will factor minus 4 and minus 1. So it does factor. Now, listen closely and watch this. You set each factor equal to 0. That would make it 0. Okay? Well, if I put this in here and I put a 1, that would make it 0. So that's one of them. So x minus 1 is equal to 0. And this could be 0. So x minus 4 is equal to 0. But that can't be 0. So you just leave it alone. It's either this one or this one that makes it 0. Now moving the 4 across and moving the 1 across, so we have an answer of 4 and 1. And it doesn't make a difference whether you put 4 and 1 or 1 and 4. It doesn't make a difference in order. Those are the two answers. X could be equal to either 4 and it would be true, or X can be a 1 and it would be true. Don't worry about this number out here in front. Okay? Now, if you have an x out in front, then that's okay. You'd come down here and put x equals 0. Okay, let's look at example 4. All right, what's the first thing we must do? We must have everything to one side equals 0. So we need to move those across. So what we must do on these problems is on one side have the letter squared, the letter, if it's there, number equals 0. All right, so we look for a common factor? No, but this can be factored as 2a minus 5 and 2a plus 5. And setting each factor equals 0. And so we have 2a is equal to 5. Dividing both sides by 2, we have a is equal to 5 halves. And moving the 5 across, dividing both sides by 2, we have a is equal to minus 5 halves. Therefore, the answer is equal to minus 5 halves and plus 5 halves. Okay, concept is get everything to one side equal to 0, factor, set each factor equal to 0, solve for the letter. All right, let's look at the next example. All right, the next example. What's the first thing we must do? We must move everything across and have it equal to 0. And then we look for common factor. Common factor is x squared. Now, when I did that, I have it factored. I don't do any form method here. This is already ready. So I have this equal to 0, and I have this equal to 0. Setting each factor. Okay. So solving this, I get x equals 0. And solving this, I get x equals 1. Therefore, the answer is x equals 0 and 1. See? So here's a case where we have a letter setting out here, and you do set that equal to 0. Now, if we had a number here, let's say we had a 4 and a 4, then we don't set the 4 equal to 0. We just set the things that have the x in them equal to 0. Okay, now let's look at some other examples. All right, looking at example 6. Now in this case, what we need to do is multiply together first. It seems kind of strange. It's factored, but it's not equal to 0. It's factored, but it's not equal to 0. So what we need to do is to multiply this back together and then move it across. All right? Because what we really need is an x squared, an x, and a number. Okay? So up here, even though this is already factored, it's not equal to 0. So you have to multiply it all back together, move it all to one side, and now you have it equal to 0. All right, so now we factor. So we'll factor 2x and x. And let's see, if we put the 4 here and 1 here, it checks by the FOR method. That's equal to 2x squared. That's equal to 4, and inside adds up. So we've done it correctly. Now we have it set equal to 0. We have it factored. We now set each factor equal to 0 and solve for x. So solving for x here, we get a minus 1/2. Move the 1 across, divide by 2. Move the 4 across, and therefore our answer is x equal minus 4 minus 1/2. And the notes, you need to notice that I didn't make a difference which one I write down first. Okay, a lot of teachers want them written in order. smallest up to the largest, whatever. What this is saying is that when x is a minus 1/2, it'll work, and when x is a minus 4, it'll work. All right, let's look at example 7. And here again, it's not equal to 0, so we need to multiply it out. Then move everything to one side, so we have 12p squared plus 17p minus 5 equals 0. And now we look to factor, okay? Well, what we're going to do then is to look to see if we can factor this. All right, well, let's see. 12, and it's a minus, so one of them has to be 5 and a 1. And let's see if we use 3 here and 4 here, that's 20, and 3, well, that's a plus 17, so if I put a 5 there and a minus there, first times the first, checks, last times the last, checks, inside, works, so therefore we have it factored, equal to 0, set each factor equal to 0, and solve. So we get p is equal to minus 5 divided by 3. Move the 5 across, divide by 3. So p is equal to, move the 1 across, divide by 4. So therefore our final answer is minus 5/3 and 1/4. Concept is multiply together, move everything to one side, set it equal to 0, factor, set each factor equal to 0, solve for the letter. All right, let's look at the last example of the tape. And here, okay, look at example 8. Here again, we have it factored but not equal to 0. Now you cannot come along and put these factors equal to some number over here, like the 6 or something else. You can only factor, set each factor equal to 0 if that's a 0. So therefore we must multiply this out. So using the FOIL method, we get x squared plus 6. Inside is plus 5x. And that's equal to 6. Now moving everything to one side, that subtracts out. So we have it set equal to 0. Factor, set each factor equal to 0. Solve for x. Okay, so while you're looking at this example, let's talk about it again, all right? The rules are, if you have a quadratic equation, if you have an x squared, x and a number, or an x squared and a number, or an x squared and x, if you have that set equal to 0, then you factor, set each factor equal to 0, solve for x. Okay, then work the sample problems in the notes.